Hello everyone, welcome to Reactify Labs. Today we will do another Leetcode problem which is called first missing positive. It is problem number 41 and it is also tagged as a hard problem. And actually it is a hard problem. Okay, because the expectation that this question has, that is something which makes the problem a hard problem. Okay, let me first explain you the problem and then I'll tell you the easy solution and also why it is a hard problem. Okay, so the problem statement says you are given an unsorted integer array nums. Okay, so you have an unsorted integer array nums and you have to return the smallest positive integer that is not present in the nums. Okay, so let's understand with an example. So this is unsorted array, right? So if you see, what is the smallest positive integer that is not in nums? Smallest positive integer not in nums. Okay, so if you see, what is the smallest positive integer that we know that exists? It is 1, right? But 1 is here. The next smallest is 2. 2 is also here. The next smallest positive integer is 3 and 3 is not here. So for this answer is 3. Okay. Let's take another example. 3, 4, minus 1, 1. Okay. So this problem says, the problem statement says that you are given an unsorted integer array. So it can be positive as well as negative integer. That's why minus 1 is present here. Now let's check. Which is the smallest positive integer that we know? It is 1 and 1 is present here. The second smallest is 2, but 2 is not present here. So for this the answer is 2. 2 is the smallest positive integer which is not present here. Okay. Let's take another example. Nums equals 7, 8, 9, 10, 11. In this case, the answer should be 1. Why? Because 1 is the smallest positive integer which is not present here. Okay. So that's all. That's the problem statement. And I explained you what it expects. Okay. Now the thing is, if you think about it, it's a very easy problem to solve. If you just have to write a code so that this works, you can do one thing like sorting. Okay, let's take this example. So what you can do here in this example is you sort this. You get minus 1, 1, 3 and 4. Okay, now you start iterating over it and see. Okay, let's take another variable current. Okay, and you initialize it with 1. Okay, now you start from here and find that, okay, if there is a positive integer, is it equal to current? If yes, it is equal to current, then you make current as 2, next one, and you move the pointer from here to here. Now you check if the current number like 3 is equal to 2. No, it means 3 is greater than 2. It means yes, 2 is missing from here. So the answer is 2. So in this case, if you see, first you do sort and then you iterate. Okay. So sorting takes n log n and iteration takes n, right? So the overall time complexity of this is n log n. Okay. And if you see the constraints, the value of n is 10 to the power 5. So n log n is well within the bounds. So even if you write this solution, first you sort it and iterate to compare and check the smallest number, it will work. Your code will run fine. Okay, but the problem statement has one more line. The problem statement says you must implement an algorithm that runs in on time and uses o1 auxiliary space. Okay, on time and o1 space. Okay, if it was only on time and no constraint on space, then you could have easily used a map and you could have compared it with current. Again, no need to sort. It will be order of n time, but space will be order of n also. So the another constraint that the question has put is o1 space also. So you cannot sort, you cannot use map. Okay, you cannot use these two things. This is what makes the problem a hard problem. Okay, this constraint here. Now let's see how we solve this hard problem. Okay, so if you see that it's something that we can leverage here, we can leverage index. Okay, how do we leverage index? So if you see, you have a nums array, right? It has some elements. Okay, so let's say it has all positive. Let's take the best case scenario, 3, 4, 5. Okay, now if you see, if somehow you can find that, okay, if this current index, if this current index can be mapped to the current element, okay, then we may know that, okay, which index is not mapped. For example, you see that yes, okay, 1 is there. It means, okay, at index 1, in ideal case, if it was sorted, at index 1, 1 should be there, right? So you are good. Now you again check at index 2, 2 should be there. Okay, so you do these comparisons, okay, somehow. Okay, you see that till index 5, everything at index 5, 5 should be there. Okay, so you see that, okay, you are exhausted, you got till the index 5, so your answer must be 6 because 6 is missing. Okay, the smallest number that is missing from this array is 6. Okay, but that is not always the case. Okay, we do not live in an ideal world, so our nums can be something like 4, 3, 1, 6. How will you do this? How will you manage this thing? So if we can somehow know that, okay, this number is 4, again there is something present at index 4. Okay, index 4 as in I know array is 0 index, but for the sake of this question we will do it index, we'll assume, okay, we will what do I say, for example, as we see that, okay, this is nums I equal to 4, right? So we will try to use this 4 as I plus 1 position. Okay, so it means when we say 4, we will not compare the 4th index of the array, we will compare the 4th element in the array. Okay, for this question we are doing that. So for some reason we know that, okay, this had something, we can do some kind of calculation here to what do you say, identify that, okay, yes, this element exists, this element is here, this index has some, means since this is size 4, since this array is of size 4, it means 4th index or the number 4 is present, because best case scenario for this would be 1, 2, 3, 4, right? So we know that yes, 4 is present. Okay, great. Now we come to 3. Again, if we see that there is an element at index 3, we can somehow do some kind of what kind of calculation we will do, I will show. So if we can do that, then we will know that, okay, yes, again index 3 is also valid. Now we come to index 1, we see that, okay, index 1 means this is also there. Okay, this kind of calculation also done. Now we see index 6, we know that index 6 is out of bounds, it means not index 6, element 6, and if we go and find the index 6 or the 6th element, it is out of the bounds of this array, so we know that we don't have to do any calculation here. Okay, now we are done. Now if we see, calculations have been done for 4, calculations have been done for this, calculations have been done for this, means if you see, calculations have been done for the first element, calculations done for the third element, calculations done for the fourth element. The only element for which the calculation was not done was second element. It means the missing number here is 2. If we somehow prove that, okay, this is the number for which no calculation was done and hence this is the missing number, we will have our answer. Okay, now if you see, we just iterated over it. Okay, we can iterate 1 times, 2 times, 5 times. In all the cases it will be order of n, because we are iterating only once as in full iteration once. It can be multiple times, even if we do it 100 times, it is still order of n. Okay, as long as this number is constant. We won't do it 100 times, of course. Let's see how we do it. Okay, so there is one more thing that we need to take care of before we start our mapping of the numbers, and that is called the negative numbers. Okay, we have to get rid of negative numbers somehow. Okay, so let's work on the test case which has the negative numbers. So 3, 4, minus 1 and 1. Okay, these are the 4 numbers, and let's mark their indices 1, 2, 0, 1, 2, 3. Okay, here we are marking index, not the element position. I will show you how we do that. How will we use the position of the element. Okay, so now what we do is, first we start iterating from here and from here. Okay, we will calculate the left and right, left, right. We see the left and right. Okay, now what we do is we compare left and right. Okay, is left and right both positive? If both are positive, we will just move left and right. Left moved forward, right moved backward. Okay, done. Now if we compare that, okay, if for some reason left is less than equal to 0 and at the same time right is greater than 0, left less than equal to 0 and right greater than 0, we will swap. Okay, in this case, if you see, it is not the case, right? It is not the case. So what we will do here is, since that is not actually, wait, we will not move right. Okay, because we are looking to move all negative numbers to the end. Okay, so we want all the negative numbers to the right side and all the positive numbers to the left side. Okay, so if left is positive, we just move left. Oh, sorry, let it be here. Okay, if left is positive, we just move left towards the right, and right will be as it is. Okay, now we again see, is left greater than 0 and right greater is left less than equal to 0 and right greater than 0? No, this is still nothing. So again we move left forward. Now you see this condition holds true. Left is less than equal to 0 and right is greater than 0. So what we do now is we swap. We swap the elements at left and right. So when we swap these two, what we do is we will make it 1, we will make it minus 1. Okay, and now left and right meet each other, and then we are done. Okay, so our final array is 3, 4, 1 and minus 1. Okay, let's see what kind of calculation we can do on 3, 4, 1 and minus 1. So now you have 3, 4, 1 and minus 1. If you notice, we did one iteration till now. Okay, one iteration. In one iteration, we just brought all the positive elements to the left side of the array and negative elements to the right side of the array. Okay, now once we have this, again if we talk about the index 0, 1, 2, 3, we will see that for 3, 4, 1 and minus 1, now we start doing some kind of calculation. So we start iterating. This is our I. We see that, okay, there is a number 3. Okay, there is a number 3. We will see what is the absolute value of num psi. What is the absolute value of num psi? In this case, it is still 3. Okay, so we take the absolute value of num psi and we will see what is nums of num psi minus 1. So basically finding the element which is present at index 2. Index 2 means finding the element which is present at third position. The same thing I talked about earlier. We have to find not the element, not the index, but instead we will be talking about the element at a position. First position is the 0th index, second position is the first index, right? So if we find the element at third position, okay, third position is index 2. So that's why we did this, nums of num psi minus 2. To find the element at index 2, we see that, okay, there is 1. So we just make it negative. We make it minus 1. Okay, great. Next, again, I comes here. Okay, again I comes here. Now again we will do this, but this time we will see that, okay, nums of nums I minus 1 is Now this time it is nums of nums I minus 1. If you see, if we do this, we will find that nums of nums I is minus 1 already. And again, if we do minus 1, we will have nums of minus 2. But this is not possible. So that's why what we will do is, whenever we get our element, we first take a mod of it. Okay, we first take the mod of it. Means when we get minus 1, we will instead make it plus 1 temporarily, and then we will try to find nums of, instead of this nums of nums I, it will be nums of absolute value of nums I and minus 1. Okay, so that makes it nums of 0, but we do not want that as well, right? What we actually want is, so what we also want is that the number we know that we reach here, we can reach this point, but we know that this is a negative number. We do not have we should not have to deal with the negative number. Okay, because what we want actually is that we deal only with the positive, because that is the whole purpose of segregating the negative numbers towards the right side. The whole purpose of segregating the negative numbers to the right side is that we do not have to deal with them. Okay, but even if we deal with them, there is no problem. So let's see what happens if we deal with them. Okay, and then I will talk about what else we have to do or we can do. So again, what we do was we just make it negative, right? So if we make it negative, it will become positive. Okay, let it be there. Now if you see, again, if I come here, because I moves forward, if you see, again, if you calculate this nums of absolute value of nums I minus 1, wait a second, did I do a mistake? Sorry, right. I did a mistake. So it should be not this. So sorry, my bad. So actually it will make this number as negative number, right? But is that right? If you make this, what is that? Nums of I think I am making some mistake here. Let me try to figure out. Actually, nums of right, my bad. So basically, I find the element at index 4. Okay, so it is nums. Okay, so actually nums I is 4, right? Yes. So it is nums of 4 minus, right, sorry, my bad. So basically what we do is so it is nums of absolute value of nums I minus 1. Okay, we'll convert this to negative or positive, right? So I think I was right earlier. So basically for this, for 3, what we did was, if we remove this again, for 3, what nums I was 3, right? So absolute value of 3 is 3. So 3 minus 1 is nums of 2 basically. So nums of 2. So we made index 2 as the negative number, right? Now again, nums of absolute value of nums I is 4, right? So it is 4 minus 1, which is equal to nums of 3. And nums of 3, if we make it negative, so negative is positive. So that is also fine. I was correct earlier. I don't know what happened to me. I just messed it up. I'm sorry for that. And okay, let's move forward. So now our I has reached here. Now if you see, nums of absolute value of minus 1 and minus 1. So this is basically nums of 0. So if we make nums of 0 as negative, we find it like this. Okay. Now if you see, if we do it again for this one, we will find that for this index, if I has reached this point, what it will do is, it will again try to do nums of absolute value of 1 is 1, minus 1, which is again nums of 0, which is again 3, and if we try to, sorry, which is this 3, and if we try to again make it negative, it will be positive, right? But we do not want that. So that's why what we should do initially is, when we had this array 3, 4, 1 and minus 1, what instead we do is, we will do another iteration. Okay, before this thing happened, we do another iteration and find the count of positive numbers. Find the count of positive numbers, and we will start our iteration and only go till that point where the positive number is there. So we will only iterate till this point. We will not iterate on this, otherwise there will be a chance of repetition. Okay, so that's why this will remain minus 3, and I will never reach till this point. I will exit from this point. Okay, so I exit from this point and we have this. Now what? Now what we need to do is, we need to start iterating again. So if you see, how many iterations have we done so far? One iteration for segregation. Okay, then one iteration for what? Count of positive, count positive. Then we did one iteration for making numbers positive to negative or negative to positive, whatever we did. Okay, positive to negative, negative to positive. And then we will do one more iteration, and this one more iteration, what we will do is, we will start iterating from here again. We will see I, and is that negative? Yes, it means it is good. Now we see, is that negative? No. The first number that we see as non-negative, okay, so basically what we find is, if nums I is greater than 0, whatever the first number that we find is greater than 0, the answer will be I plus 1. So the answer will be 2. So if you see, 2 is missing from here. Okay, so we did one more iteration. Why? To find our answer, right? So totally we did 4 iterations. So basically our total number of operations were 4n. So still it is order of n. Let's try to dry run it on another example. Okay, let's dry run it on another example, and let me take some example by myself. So if let's say we have 4, 3, 7, minus 4, minus 9, minus 100, 100, 17. Okay, now if you see, what we do first iteration, we do the comparison, we did the segregation. Okay, so what do? We check left less than equal to 0, right greater than 0. If this is the case, then we swap, right? Left is less than equal to 0, right is greater than 0, does not help. Still no. Now we move left here, still no. Now we move left here. Now in this case, if you see, left is less than equal to 0 and right is greater than 0. So we swap. We get 17 and we get minus 4. Correct? Now we move both left and right. Left is moved, right is moved. Now if you see again, yes, 100 and minus 9, again it will swap 100 minus 9. Now if you see, left will reach here, right will also reach here. So left and right at the same place, we stop the iteration, and if you see, we have the segregation of left and right. Now we count. The elements. How many positive elements are there? If you see, we have 5 positive elements. So we know that our count is 5. So we know that our third iteration will go till this point only. Okay. So let's use the index 0, 1, 2, 3, 4, 5, 6, 7. Okay. These are indices. So what we do now is, we start iterating. We see that, okay, what we do, nums of absolute value of nums I minus 1, right? We make it negative, negate it, right? If it's positive, make it negative. If it's negative, make it positive. We negate it. How do we negate it? Nums of absolute value of nums I minus 1. So if you see, nums of 4 minus 1 is 3. Let's make nums of 3 negative. So nums of 3 is negative. Now again 3 minus 1 is 2. So let's make nums of 2 negative. So nums of 2 is again negative. Now if you see nums of 7 minus 1 6. So let's make nums of 6 negative. So nums of 6 is already negative. Let's make it positive. Then we make nums of 17 minus 1. So nums of 16. But we know that 16 is out of bounds, so we have to put a check that okay, if it is out of bounds, it means it cannot be considered. Okay, so let's skip that. Nums of 100, again it will ask for nums of 99, so again that is gone. So we know that since we have reached till 100, our pointer has reached till 100, it means we are good. We do not need to do any more calculations. We stop here. Okay, now what do we do? In the fourth iteration, we find our answer. How do we find our answer? We find first I for which nums I did not become negative. Nums I is greater than 0. So if you see, first I for which nums I is greater than 0 is I is equal to 0. It means our answer is I plus 1, which is equal to 0 plus 1, which is equal to 1. So the first element which is not present here is 1. You might ask why did we not do any calculations for 17 and 100, because they were out. So if you see, the size of the array is 8. So it means array has only 8 elements. You will find the answer somewhere between 1 to 8 or 1 to 9 basically. So you'll find somewhere between 1 to 9. Your answer will be somewhere between 1 to 9. Okay. So if your array has size n, your maximum answer can be n plus 1. Okay. So that's why 17 and 100 were worthless for us. Okay. So that's what we did. Because this, I hope you understood this point. Because if you have, let's say 10 size array, the best case you can have is you have 1 to 10 numbers. So your answer will be 11. The worst case, if you have any number missing from 1 to 10, if let's say you have 11 to 20, it means your answer is 1 in that case. So the best case or the worst case, whatever you say it, your answer can never be more than n plus 1. Your answer can never be more than n plus 1. So that's why it is perfectly fine for us to skip those other numbers. Also, in the worst case or the best case, I don't know what to say it, it's n plus 1, but not always. If you see you have n elements, okay, and out of which m elements are negative. If m elements are negative, then your answer cannot be more than n minus m plus 1. So let's say if you have 10 elements and out of which 5 elements are negative, then you know that you only have 5 positive elements. If there are only 5 positive elements, you can best case have 1, 2, 3, 4, 5. In that case, your answer will be 6. So n minus m plus 1, 10 minus 5 plus 1, which is 6. So that's why we skip the elements. We skip the index for those elements which are outside our count, Okay. So that's all. That's all in this video, and I hope you liked it. I hope you learned something new. This is actually a good problem, and I really enjoyed making video on this. I also had to think a lot, and I messed up a little in the explanation, but I hope that's not a problem. So yep, thanks for watching. Please remember to like, share and subscribe, and have a good rest of your day, night, whatever it is.